Today I will present you the result of a work that we have made in collaboration with Lucy, and we wrote a paper on this work. So the work has been presented at the SIP General Assembly this year in Nantes, and the name of the paper is A Protocol to Perform Usage-Oriented Eco-Design. So here is a brief outline of the presentation that I will make. First of all, we will talk about the state of art and the introduction and context of the research. Second of all, I will present you the protocol that we developed in order to address user in eco-design approaches. Then we will see an application of this protocol on a case study. And finally, I will finish my presentation with the discussion and the future work that we are going to do on this specific topic. So the work that we have made started from a statement, which is that today the design and the environmental impact of consumers' products have been widely studied, and we observed that a focus was made on the improvement of the manufacturing phase and end-of-life phase. That means that a lot of eco-design approaches are focusing on these specific life cycle phases. For example, greener processes with the optimization of energy consumption, cleaner processes, etc. And also for the end of life, we have a lot of design for X strategies, such as design for reuse, recycling, remanufacturing. But in fact, for the majority of most consumer products, the environmental impact of the global life cycle is dominated by the use phase. And this is mainly due because of energy consumption of these products, but also the use of other consumables such as water or any other kind of consumables. And we also observe that this life cycle phase, the use phase, has a lot of difficulty to be integrated into current eco-design approaches. And today's solutions are more concentrated on improving products technology and component efficiency in order to produce more efficient products. But we are postulating that how better a product is designed efficiently, if it's not well used, it can create a lot of environmental impacts and degrade the environmental performance of the products. So we are thinking that new solutions should be investigated, taking into account the user into eco-design approaches of the use phase. And so there is a necessity to consider user behavior in this environmental impact and to find solutions to influence it and to modify it in order to reduce this impact during the use phase. So during the last decades, the design for sustainable behavior research field has worked on adapting product design in order to modify the behavior of user and to improve the environmental performance in use of the product. So this is a figure that have been made by Lucy and that classified different design for sustainable behavior strategies. We should notice that in order to be efficient, of course, these strategies need to be implemented on the product. And some of them are more on monitoring user behavior, some of them are more on influencing it by giving information, etc. So in our context, in the work that I will be presenting today, we are proposing to use design for sustainable behavior approaches in order to address user experience as a part of the eco-design process. And we postulate that effectively the decrease of environmental impacts during the use phase can only be effective with the consideration of the user. So we developed a 6 steps protocol for usage-oriented eco-design, And this protocol is based on two different analyses of the use phase. The first one is a macro level analysis of the use phase, which will help the designers to analyze the main contributors of environmental impacts during the use phase. And the second one is more a micro level analysis that will help the definition of good design intervention strategies to influence user behavior and limit the environmental impacts in use. So here is a brief outline of our protocol. So the first three steps are corresponding to the macro level analysis. So first of all, the designers have to identify the different types of moment that we can have in the use phase. And then there is an environmental impact assessment and a selection of the most impacting moments in order to improve them. So I will illustrate all of these steps after this slide in order to have a better overview of what is done in each step. And then the last three steps, so step 4 from step 6, are a micro level analysis of the use phase, and this will help the identification of design solution for the product and connect user experience activity to product features. Then the final step aims to calculate the overall environmental benefits of the solution that have been retained for the project. So I will go through each steps in order to better understand our methodology. So the first step is the identification of the different types of moments that are composing the use phase. So here you have a representation of the entire life cycle of a project, from raw material acquisition to the end of life. And you can see that the use phase has been divided into different moments. So a moment can represent a change of state of the product. And in each moment you have different activities that the user can perform with the product. And the combination of each moment is covering the entire use phase. So for consumer product, we identify 7 different types of moments, which are installation, learning, core use, maintenance, storage, upgrades, and decommissioning. So in the case study that we took, we decided to study a coffee machine and to improve the environmental performance in use of a coffee machine. So we decided to work on this typology of product because the use phase is representing a majority of the environmental impact on the global life cycle. And there are a lot of usage drift that have been observed on this kind of product because people are not switching off the machine or they are not using it correctly. So we defined the 7 different types of moment for the coffee maker. For example, moment 3 represents the core use, which is making one coffee, which will be repeated 3 times a day for 3 years, which is the lifetime of the machine. So we divided the entire use phase on this product into these 7 different moments. After that, we have to do the use phase environmental impact assessment. So it consists of 3 stages. The first one is to identify and analyze all the flows that are associated to each moment. So the elementary flows such as energy, water, or any other kind of consumables. And to also study how these flows are solicited by the user. So every task is given an in-use environmental performance, and thanks to a life cycle analysis software, we can generate environmental impact of the global use phase. And we still need to consider the other life cycle phases, such as manufacturing, end of life, in order to still have this global vision and effectively see if the use phase is representing the most important impacts. So Yeah, this is the example of this step 2 for the coffee maker. So I took the example of the moment 3, which is the core use of the product and which is make a coffee. So here you have the input flows that have been identified and the output flows. So as an input we have energy, water, coffee, and as output we have coffee but as a drink, coffee grounds and waste, etc. So we need to really identify each of these elementary flows and how they are solicited by the user during each moment. So step 3 is to select the most impacting and improvable user moments in order to identify the level of action that we have through the modification of user behavior. So the environmental impact associated to each moment are broken down into 2 different kinds of impacts. The first one are the impacts related to product flows, and the second one are the impacts related to user solicitation. So if the impact related to product flows are representing the majority of environmental impacts, it means that technical improvement should be made. So the design of the product should be rethinking by designer in order to limit the consumption of these flows. And if we identify that the impact are related to user solicitation, so there is a necessity to analyze strategies that connect user and product in use. So it will be the next, the micro-analysis that will come after step 3. So step 4, so it's the beginning of the phase 2, which is the micro-level analysis of the use phase. This life cycle, step, comes after identifying that we need to find solution to improve user solicitation. And these steps aim to identify possible design intervention strategies to improve product usage on the studied product. So from the literature and from a classification of different design for sustainable behavior strategies that we have made, a designer can select different kind of strategies they want to test according to the typology of product, the level of intervention of the user, the objective of the company. They need to decide which kind of strategies they want to test from this list. So there are a lot of examples in literature and there are a lot of classification existing. And for in our case, we identified 4 different design intervention strategies for our products. The first one aims to steer the user. So it's just a written information that have been implemented on a machine and that says to the user to turn off the machine right after he made a coffee. The second one is the strategy that will force the user to automatically switch off the machine after he's making coffee. So the machine will stop automatically. And after that, we also implemented we also created 2 other prototypes. So one of them is the eco-feedback strategy. So a screen has been implemented on the coffee maker and energy consumption is given to the user in real time. Then he can have an overview of how much energy he is consuming. And the last one is combining the eco-feedback with an objective to reach. So the screen is displaying an objective of 10 water for doing a coffee. And there is a little smiley that say, okay, you didn't consume too much energy or not. And so step 5, it's effectively to test these strategies on the product and see which one can be implemented. So the objective of this step is to measure the efficiency of the design intervention strategies that we selected and to identify the best implementation of on the product. So in our case, we have tested all of the prototypes on 36 regular coffee maker users. And we measure the environmental performance in use while they were making the coffee, like energy consumption, water consumption, and also coffee consumption. And we have made some observation of the use phase in order to understand what will be the variables that are influencing environmental impact in use and how the user are responding to an instrumented product. There is not... So sorry for that. This is the first result of this experimentation. So we can see that for each of the 4 strategies that we implemented, we observe a really decrease in energy consumption. So in fact, in blue you have the energy consumption for making one coffee on a non-instrumented coffee machine, like a regular one. And then the 2 other tests are on instrumented machine. So for each of the strategies, there is a significant decrease in energy consumption. We observe a significant decrease for each of the group that we have tested. I should also add that we tested the strategies on 36 users, so 12% for each strategies. So maybe we need to have a broader panel in order to really validate the results statistically. I'll do that. And this is the second result that I wanted to show you. So after testing all of the implemented coffee machines, the user have answered to a questionnaire on their perception of the strategies. So this is a qualitative questionnaire that helps us to measure the level of perception of efficiency, usefulness, and intrusiveness of the strategies, because it needs to be taken into account for designer in order to find which strategies is the most well perceived for the users. Yeah, I won't go too much in detail in these results, but we can observe that strategy 2, it's eco-feedback strategy, and we can observe that the perception of the efficiency and the usefulness of this strategy is really high for the users, such as the objective strategy with the little smiley. And the automatic switch off, it is perceived as the most intrusive strategies for the different users. So this is quite interesting to analyze also this kind of results. So finally, in order to implement the results into design activity, we need to calculate really the real environmental benefits related to the design implementation. So we need to consider and to balance the environmental losses that we have because we have added some technology on the machine, such as sensor and screen, with the environmental gains due to the modification of user behavior. So we need to perform a life cycle analysis in order to balance these 2 aspects. And I presented you for, in our case, only the results on the impact energy consumption, because I couldn't present a lot of impact on these slides. But we can see that for each of the strategy, so here is the energy gain in use that we observe, which is, for example, minus 30% for return information or minus 44% for the objective. But if we balance the environmental and these energy gains in use with a global life cycle vision, we have only a gain of minus 34%, for example, for the objective strategy. So that means that it's still good because we observe for this indicator, which is energy consumption, we still observe good results. But we need also to have multi-indicator vision, and it's not presented here, but the designers can have this kind of table in order to take their decision of which strategy is the best. And finally, we can also link this result with the level of acceptance of the user regarding the strategy. So, for example, this strategy, which is persuasive technology, which forced the user to automatically switch off the machine, it's not really well perceived, so maybe it's not the better strategy to find, to implement on the product. So to summarize, this protocol is supported designers during design activity to address user experience as a part of the eco-design process. And in fact, in this protocol, we are combining two approaches, which are the macro and level analysis and micro level analysis of the use phase through a formalized methodology, because there is no really formalized methodology linked with design for sustainable behavior research field for the moment. However, we observe some limitation because in our experimentation we didn't take into consideration the loss in performance of the strategies over time, because we only tested the strategies one time in a lab with the user. But if, for example, a written information is implemented on a product, after 1 year of using the machine and seeing the message, maybe the user will just be will not notice the message anymore. So I think there will be a loss in performance over time, and there are some algorithms that are existing that are measuring this. So maybe we need to take into account this. And it is also heavy to implement in industry, so we are currently working on developing a tool that can help to support and implement the methodology. Yeah, I think this is quite all. So just to remind you the structure of our protocol and to highlight the three main benefits of this methodology. It aims to get a more efficient adaptation of product's feature to the user, to get environmental performance in use, to take into account user behavior in product design, and also to have a better comprehension of the share of user behavior in environmental impact in use. So, and it has been implemented on a case study, so it's yeah, it's the three main benefits. So thank you. And